Are you ready?
CES 2025 kicked off with a bang, and from day one, it's clear we're witnessing a massive leap in AI and tech that's reshaping everything: personal devices, gaming, cars, robotics, even how industries operate. Las Vegas is buzzing with over 4,500 exhibitors from around the world, and AI is the star of the show. The scale is mind-blowing. 232,000 square meters packed with groundbreaking tech that's taking innovation to a whole new level. And honestly, NVIDIA is stealing the spotlight. Jensen Huang, NVIDIA's CEO, walked onto that stage, and you could tell something big was coming. His keynote wasn't just another presentation, it felt like a preview of the future. NVIDIA's new GeForce RTX 50 series GPUs were front and center, and they're built on the Blackwell architecture, which is already being talked about as a game changer. The specs alone are wild. The flagship RTX 5090 has 92 billion transistors and can handle 3,352 trillion AI operations per second. To put that into perspective, this isn't just better, it's a whole new level of performance that makes even the current top-tier GPUs look slow. The real surprise, however, was the pricing of the RTX 5070. Priced at $549, this GPU delivers performance that rivals or even surpasses the RTX 4090, which was previously seen as a powerhouse. Offering that kind of power at such an accessible price point is practically unheard of. But it's not just about raw performance. NVIDIA's new DLSS 4, Deep Learning Super Sampling, elevates AI-powered rendering by generating 3 additional frames for every 1 frame the GPU renders. This results in smoother gameplay, enhanced detail, and significantly reduced system strain. And while gamers will undoubtedly benefit, this technology goes far beyond gaming, with applications in industries like architecture, filmmaking, and beyond. But NVIDIA didn't stop there. They unveiled their Cosmos platform, designed to simulate the real world for training AI systems. Imagine being able to create entire virtual environments where robots and autonomous vehicles can learn how to navigate complex situations before they ever hit the real world. Training in a simulation like this saves time, money, and risk. Instead of sending a robot into a cluttered factory and hoping it doesn't crash into something expensive, developers can run thousands of virtual scenarios in minutes. Speaking of autonomous vehicles, NVIDIA's partnership with Toyota was another jaw-dropper. Toyota's upcoming vehicles will be powered by NVIDIA's Drive AGX Orin supercomputer and Drive OS operating system, making their advanced driver assistance systems smarter and more reliable. And Toyota's ambitions go beyond self-driving cars. They're building an entire smart city called Woven City at the foot of Mount Fuji. And the foot of Mount Fuji, it's set to launch later this year and will be a living lab for AI, robotics, and autonomous vehicles. Toyota even revealed plans for flying cars thanks to their collaboration with Joby Aviation. It sounds like science fiction, but it's happening. AI wasn't just taking over the automotive space, it was everywhere. NVIDIA's approach to agentic AI took things to another level. These aren't just chatbots or voice assistants. These are AI systems that can reason, plan, and act independently. They don't just spit out answers, they solve problems in real time. NVIDIA's AI blueprints make it possible for companies to create custom AI agents for tasks like fraud detection, customer service, or even optimizing supply chains. It's AI stepping into roles that require decision-making and adaptability. PCs are also evolving fast. At CES, companies like Intel, AMD, and Qualcomm showed off their latest processors with neural processing units, NPUs, that handle AI workloads directly on the device. This means faster responses and more secure processing since the data doesn't need to be sent to the cloud. Microsoft's Copilot Plus PCs take this a step further, offering AI-powered features that make your interactions feel conversational rather than command-driven. Dell also showcased AI PCs that
use Edge AI to process data locally, making them more efficient and responsive. One of the most surprising AI-powered devices was from Roborock, a vacuum cleaner with a robotic arm that can pick up objects like socks and shoes before it starts cleaning. AI isn't just helping it navigate, it's helping it understand its surroundings. And for those who want more comfort at home, there was Jenny, the robotic dog designed for people with dementia. Jenny responds to voice commands, has touch sensors, and can rest quietly on someone's lap for hours, providing companionship without any of the upkeep a real pet requires. Healthcare tech also made waves. AI-empowered tools like AI Doc and NeuroClues aim to improve diagnostics and predict diseases more accurately. And in the environmental tech space, a company called Molluscan is using mollusks, yes, mollusks, to monitor water quality. These little creatures are equipped with sensors, and if they detect pollution, they send real-time alerts. It's an innovative mix of nature and technology tackling real-world problems. The day one announcements didn't stop there. NVIDIA's reveal of Project Digits was one of the most ambitious unveilings. This is a personal AI supercomputer, small enough to fit on a desk, but powerful enough to run 200 billion parameter models. It's built with the Grace Blackwell superchip, combining a 1 petaflop FP4 compute capability with 128 gigabytes of DDR5X memory. The fact that this much power is available for around $2,000 is insane. It's designed for developers, creators, and anyone who wants the full power of AI right at home without needing to rely on cloud services. The push for physical AI that interacts with the real world, is also leading to massive developments in robotics. Jensen Huang called it the ChatGPT moment for humanoid robots. Instead of wheeled robots designed for specific environments, humanoid robots can move and function in the spaces we already live and work in. Companies like Tesla and Figure Robotics are making huge strides in this area. NVIDIA's platforms provide the simulation and processing power needed to train these robots using virtual scenarios before they ever hit the assembly line. NVIDIA also emphasized the importance of scaling laws in AI development. Models don't just get better by being fed more data, they improve through smarter processing at every stage. Pre-training feeds them massive data sets to build a foundation, post-training refines their skills through reinforcement learning, and test-time compute allows them to reason and break down complex problems on the fly. This last phase is what's driving the next generation of models like Gemini and making AI capable of handling PhD-level math, coding, and problem solving in ways that were impossible a few years ago. The sheer volume of data being created is staggering, doubling every year, and NVIDIA's approach to using synthetic data is a clever workaround for the limitations of real-world data sets. Autonomous vehicle companies need incredibly diverse and detailed data to make their systems safe and reliable, and synthetic data fills the gaps without requiring millions of real-world tests. Tesla might have millions of cars collecting data daily, but for most companies, synthetic environments are the only way to compete. The automotive industry leads the AI charge alongside others. Mobileye, Intel's autonomous driving arm, introduced their Surround ADAS system, delivering a 360-degree view that enhances road safety. Their Chauffeur platform elevates this further with a fully autonomous driving system tailored for mobility as a service. Picture fleets of fully automated ride-sharing cars navigating streets with precision and coordination. CES 2025 showcases AI as the core of innovation across every industry. Gaming, robotics, healthcare, and home appliances rely on AI as the driving force behind their progress. Day one alone brought an overwhelming wave of announcements, and much more awaits. Is everything moving too fast? Or is this just how progress is meant to happen? Let me know what you think. Thanks for watching, and see you in the next one.